this chapter, we will be discussing on numerical integration. Already you have enough knowledge on evaluating the single and double integration in your calculus courses. Now, in this chapter, let us discuss about how to evaluate the single integration using the following methods. The methods that we are going to discuss is trapezoidal rule, Simpson rule. In this Simpson rule, we have two methods. One is the Simpson 1/3 rule, another one is a 3/8 rule, and the final one is a rhombus rule. First, let us start with trapezoidal rule. It's a very simple method, and the formula of this method is easy to memorize. So before we go look onto the formula, let us see the simple example. While on evaluating this example, I will explain you how to memorize the formula for trapezoidal rule. So the question is, use the trapezoidal rule to evaluate the integral -1 to +1 dx over 1 plus x square. Here the integrating function f of x is equal to 1 over 1 plus x square. 1 plus x square. And it is given that you have to take 8 intervals, and this is the most important thing in numerical integration. So the number of intervals, the more the number of interval will leads your result to the accurate value. So here the number of interval is defined. So according to the trapezoidal formula, we need the value of h. So to calculate the value of h, the formula that we are going to use is b minus a over the number of interval, which is nothing but 8 in the given problem. So b is your upper limit of the given interval and a is the lower limit of the integral. So this is your b and this one is your a, lower and the upper limit. Upon substituting the values of a and b to get the value of h, we get it will be 1 minus of -1 divided by 2. So divided by 8. So which is equal to 2 over 8 is nothing but 0.25 as mentioned here. So now we got the value of h and we defined f of x. Using these two terms, let us form a table to calculate the integral value. Look at this table. This table is formed with the basic results of h, of basic results we obtained before. h is equal to 0.25 and f of x is equal to 1 over 1 plus x square. So now divide the integral -1 to +1 into equal parts with the difference of 0.25. So if you look at this difference, it will be 0.25 and also here 0.25, and each and every data is having a difference of 0.25. So now for each x, let us find the corresponding f of x. So now you substitute this x in your f of x. So what happens for the first value? F of -1 will be 1 over 1 plus of -1 the whole square. The result will be 0.5. Similarly, now change your x as -0.75. So that is equal to 1 over 1 plus of -0.75 the whole power 2 will leads to the result of 0.64. Likewise, you find the value of f of x for the remaining terms. Now, let us see the formula of the trapezoidal rule. So, according to the formula, the required terms are h, y0, yn and 2 times of the remaining term. So usually we denote f of x as y. So we take the first value of your f of x as initial value, which is y0, and the second one y1, and similarly the successive values are denoted as y2, y3, y4, y5, etc. The final value is y8. Let us alter the trapezoidal general formula to our given data. So the value of h is 0.25 over 2 y0, and the final result is the final value is y8, and 2 times of the middle value. What are the middle values that we have? y1, y2, y3, y4, y5, y6, y7. So this is your y0 value 0.5, and this is your yn value, y8 value 0.5, 2 times of y1, y2, y3, y4, y5, y6, and y7. On simplifying, this expression will lead to the value of 1.5656, which is the numerical value for the given integral minus 1 to plus 1 dx over 1 plus x square. Now let us see what is the actual value of the given integral using the basic techniques that we have learned in calculus 1. So the integral of 1 over 1 plus x square dx is tan inverse of x. So this is the integral of the given term. So now when you apply the upper limit for x as 1 and the lower limit as minus 1, and tan inverse of 1 is pi over 4, and the tan inverse of minus 1 is minus pi over 4. Upon simplifying, pi over 4 minus of minus will become plus pi over 4. So this is nothing but 2 pi over 4, which is equal to pi over 2. Here the value of pi is 3.14, so on. So on dividing by 2 will leads to the result of 1.5708, which is rounded to 4 decimal places. Now look at your calculated value, actual value, and the numerical value. The numerical value is 1.5656 and the actual value is 1.5708, which is near to our numerical value is near to the actual value. The difference of this value will give you the error that we find in our numerical terms. I hope this lecture is clear to everyone. Thank you.